Hello everyone, we are back with another video. In today's video, we will be studying about another geometrical theorem and its proof. In the previous video, we had studied about Apollonius theorem, which was again a very important theorem in geometry. And in today's video, we will be studying about Euler's theorem. I've written Euler's theorem in geometry particularly because we have many theorem which are namely Euler's theorem in mathematics. One is in complex number, other relates the number of faces, but we have to study Euler's theorem which relates the distance between the circumcenter and the incenter of a triangle. So now we shall begin. The situation is something like this. We all know that each triangle has 2 points, namely circumcenter and incenter. We denote circumcenter by the letter O and incenter by the letter I. If I tell you what incenter is, then it is the intersecting point of angle bisectors of the triangle, and the circumcenter is the intersecting point of the perpendicular bisector of the sides of a triangle. So we are going to relate the distance between the two with the circumradius and the inradius. So in geometry, Euler theorem states that the distance d between the circumcenter and the incenter of a triangle is given by d equals to root of r into r minus 2r. If I tell you capital R denotes circumradius, circumradius is this distance. The distance from the circumcenter to any side of the triangle is called the circumradius. In and small r denotes in radius. In radius is the distance, perpendicular distance from the incenter to any side of the triangle. Like in this diagram, IP, if I name this point P, that is if I drop a perpendicular from point I onto the line BC, then and the point where I drop this perpendicular, let it be P, then IP is the is the in radius, and OC is the circumradius. So Euler's theorem relates the circumradius, the in radius, and the distance between circumcenter and incenter, which is d is equals to root of r into r minus 2r. If I square both sides, then I get this expression, or if I simplify it, then I get another important expression which is worth remembering, and it is 1 by r plus d plus 1 by r minus d is equals to 1 by r. I've written the notations. R denotes circumradius, capital R, small r denotes in radius, d is the distance between the circumcenter and the incenter, and O denotes circumcenter, I denotes incenter. So I've explained you the situation and what Euler's theorem say. Now we will begin with the proof. I have drawn a diagram in which I have done many constructions, but it may not be clear because it is done manually. So I'll share uh, a photo which has the diagram of this scenario very clearly. I've been sharing the notes and what I write with you from the previous video, and I also share in this video along with this video. The notes and the photo will be in the description. So let's begin with the proof. I've drawn the triangle and the circle. If I join A and I, guys, you should follow my hand because it is not drawn in front of your eyes, then you may not catch what I'm trying to say. So you should observe the movement of my pen very carefully. Let us join A and I, this A and I, and extend it. If we extend it, it meets the circle at point L. And if we do this, then for this arc, L is the midpoint. I've written this, let the extension of AI intersects the circumcircle at L, then L is the midpoint of arc BC. Now let us join point L and circumcenter, that is O. If I join L and O and then extend it such that it meets at point M, on the circumcircle. I've written it. Join LO and extend it such that it meets circumcircle at M. Now we'll drop a perpendicular from in center upon the side AB, and let the point where we drop the perpendicular be it D. Let it be D. This is the perpendicular. Then I told you this will be the in radius. Now ID is equals to in radius, I told you before. Now if we observe, then triangle ADI, which I have shaded a bit, and triangle MBL MBL are similar. Now we have proved these two triangles similar by the angle axiom. If we know similarity, then we know this axiom. We to prove two angles equal and then prove the two different triangles to be similar. In these two triangles, angle BML is equals to angle DAI because they're in the same segment. This is a theorem relating to circle. And angle ADI is equals to angle MBL. Now you would be wondering why angle MBL is equals to 90 degree. This is another theorem relating to circle. If we look closely, then this triangle MBL, BL is the diameter of the circle, the circumcircle. So this angle MBL comes out to be 90 degree. This is another theorem which we study in circles. So we have proved two angles equal. Therefore, by angle axiom, triangle ADI is similar to triangle MBL. Now, if they are similar, then ID upon BL is equals to AI upon ML. If we cross multiply, then ID into ML is equals to AI into BL. ID was equals to the in radius and ML was equals to twice the circumradius. Therefore, we get this expression. Now we join B and I. Turning over to the next page. Now, angle BIL was equal to half the angle A plus half the angle ABC. The angle IBL was equals to angle half the angle ABC plus angle CBL, which was equals to angle ABC by 2 plus angle A by 2. This implies that angle BIL was equals to angle IBL, which implies BL was equals to IL. Now, since in the previous expression we wrote AI into BL was equals to 2 twice of circumradius into in radius, therefore we can now replace BL by IL because they are equal. So therefore the expression now which we get is AI into IL is equals to twice of circumradius into in radius. Now if we extend OI such that it intersects the circumcircle at P and Q, then PI into QI is equals to AI into IL, which is equals to 2 times of circumradius into in radius. Therefore, capital R plus D multiplied by capital R minus D is equals to twice circumradius into in radius. Now the formula, applying the formula a square minus b square is equals to a plus b into a minus b, we get this. Now on simplifying the expression, we get d is equals to root of r into bracket r minus 2r. Therefore we have proved the Euler's theorem for geometry. Now if we summarize, then we can say in a triangle, if the if the distance between the in center and the circumcenter is d, and the in radius is equals to small r and the circumradius equals to capital R, then d is equals to root of r into r minus 2r. If this is point I, this is in radius and this is circumradius. So according to Euler's theorem, we get this expression, and if we simplify it, then we get this expression. These two expressions are worth remembering, and this theorem is very helpful while solving questions related to geometry. I hope you would have understood the theorem. If you like the video, please share it more and more, and please tell in the comments which video you want the next. Thank you all.